So the focus of the Year 4 lesson was developing understanding of place value with decimal numbers, just working for the moment with whole numbers and tenths. And in particular, I wanted to move them on from thinking about place value in the additive sense, so thinking about 1.2 as being 1 whole and 2 tenths, to thinking about it multiplicatively, so understanding that 1.2 is also made up of 12 tenths. And in time, as we move on to hundredths, we'll extend that so that, for example, we'll think that 1.2 can also be made up of 120 hundredths. So this is the third lesson in a series of lessons on decimals. We have so far just been working with tenths, and we'll continue to do that probably for the first 5 lessons or so before moving on to working with hundredths. We started the unit by introducing the decimal notation and getting children to really try and understand what the decimal point is doing, and particularly looking at place value in decimals as using the scaling model. So understanding that 10 is 10 times smaller than 100, 1 is 10 times smaller than 10, and a tenth is 10 times smaller than 1. And so that was the focus of our first lesson, getting them familiar with decimal notation. And then the second lesson, we looked at working with tenths within 1. We looked at partitioning 1 in different ways, and we got them started introducing them to writing decimal numbers which bridge 1, so numbers like 3.4. So at the start of the lesson, they'd just seen numbers like 3.4, but we'd not done very much at all of understanding those numbers. I think the class is probably similar to many classes with children who kind of historically through school have attained a wide range of scores and tests and have had a wide range of maths experiences in the classroom, in their perception of maths and in how successful they've been in maths. So there's some children who are very quick to pick up new concepts and have historically kind of raced through with their work, and other children who've struggled more and have had earlier in the school support and intervention with their maths. The challenge for the higher attainers comes in the form of what we call the STAR challenges. So we've worked really hard to try and develop our understanding of differentiating through depth, which means that they're still working with tenths, but they're trying to think about it more deeply, which can mean one of several things. So in the first part of the written activity, I wanted the children that were picking it up more quickly and the higher attainers to be comfortable with partitioning the decimal numbers in many different ways and understanding the many different ways they could do that. In the second part of the lesson, when we moved on to the multiplicative understanding, I wanted those children to really be able to think about many, many different ways of representing a decimal number with symbols. So they were looking at things like 34 tenths written as a fraction. They were looking at things like 30, lots of 1/10, 30 multiplied by 0.1, add 4 multiplied by 0.1, and trying to decode lots of those different ways of representing a decimal number. And for me, I think that's where a lot of the challenge comes on, is making connections and being able to be incredibly flexible in their thinking. I worked for a bit of the lesson with a boy called Charlie, who'd quite quickly worked through being able to represent 3.4 as 34 multiplied by 0.1, 34 lots of 1/10. So he moved quite quickly onto the STAR challenge. And for him, I was listening to him talking about his thought process and trying to identify which of the statements that corresponded to the symbolic representation of 3.1 were correct. And he was able to do that relatively confidently. My feeling is it was a good challenge for him, and he had to slow down and think and slow down and take his time to do that in a way that he actually probably hadn't had to do in the first part of the activity. He moved through that pretty quickly. And I guess that's what I'm aiming for with the STAR challenge, is to get those children that have raced through work quickly or have picked up concepts quite quickly to slow down, stop, think and make connections. And sometimes I think where the errors come is when they almost start racing procedurally through the STAR challenge as well. And that's really what I want to stop them doing. And I really want them to kind of think deeply and more slowly at that part of the lesson, if that makes sense. STEM sentences is something that we saw the Chinese teachers use quite a lot when they were over here, and I guess I'd never really thought about before, because in some ways it feels quite old-fashioned, but actually now I suppose I see them almost as a representation in themselves and as a real scaffold for some of the children. So I plan the STEM sentences really carefully. I guess my thought process starts from what's going to be difficult about this concept, and then I think about the physical representation I'll use to pull out that difficulty point, and then think about a STEM sentence that we can say lots of times that we'll still have in their head when we've taken the physical representation away. So for example, 10/10 is equivalent to 1 whole. I just want that to absolutely trip off their tongues, so that when we're saying, okay, we've got 16/10 here, how are we going to write 16/10 as a decimal? We can say, what do we know about 10/10? 10/10 is equivalent to 1 whole, and that will help them to structure their thinking. I put a lot of thought into them, and I try not to have too many, just ones that are going to really pull out the essence. It was quite interesting actually thinking after that lesson, because the previous lesson, one of the children, Janelle, had said, the 10ths sit to the right of the decimal point. And I thought that was quite a helpful STEM sentence, because often children are quite scared of the decimal point. And I'd really, in previous lessons, tried to make them just see the decimal point as a marker. All the decimal point is doing is telling us where the 10ths are. But thinking about today's lesson, I'm not sure how helpful that was, because I think that had set up a misconception. So we were all saying the 10ths sit to the right of the decimal point. But I'd not thought far enough ahead, because today I was wanting them to think multiplicatively. And so we were thinking of 1.6 as 16/10. And when Sian wrote 16/10 as 0.16, I think she was doing what we'd said to do in the STEM sentence, which is the 10ths sit to the right of the decimal point. So she'd written 16 to the right of the decimal point. So that's definitely something for me to go away and reflect on, how that contributed to that misunderstanding. And I guess it is always a kind of a process of that. What was it about the lesson that helped, and what was it about that lesson that I didn't get right that time? And I think that STEM sentence is definitely something I will reflect on after the lesson. When I'm asking the children to explain their reasoning, I suppose it's helping them try and get to a deeper level of understanding that's going to almost prevent common misconceptions occurring. So I think there was quite a nice example at the end of the lesson when Rishi was talking about 3.1 and why that was equivalent to 31/10. And he talked about there being 3 10/10 and 1/10. And I suppose wanting the children to really understand comes from wanting them to slip into things which might go wrong otherwise. So common misconceptions when working with decimals, things like when we multiply by 10, we're just going to put a 0 on the end. And by having thought about things in lots of different ways and really understood structurally what's behind the numbers, almost what the numbers are saying to them, I'm hoping that it will help them avoid some of those common misconceptions. In the course of the lesson, I would try to have most of the teaching related very tightly to what that teaching point is. So at one stage at the back of the class, I was working with Santino and Tawana's table, and they were struggling with the task itself and needed me to go back over the first, I think it was the partitioning one that I was working on with them. So understanding that 3.5 kilograms could also be written as 3 kilograms, add 0.5 kilograms. So once we'd looked at that, they were then quite able to quite quickly kind of work through the others. But other things that came up that were incidental points, I probably wouldn't pick up in that lesson, and I'd probably try and pick those up after or plan for them more specifically in a different lesson. So there was another pair of children who were getting in a bit of a pickle with trying to write equivalent fractions as tenths. And that's something that we will need to go back to. But as the focus on the lesson was really trying to write decimal numbers as decimals rather than as fractions, I decided that I didn't want to spend time picking up on that misconception in the course of the lesson. One of the sayings that the Chinese have is about letting the kite out and reeling it back in again. And I found that really helpful in balancing giving children space to make sense of the maths in their own way, but also not losing sight of what is your tight teaching point. So when we looked at the 1.2 metres, I think Janelle said something about 8/10 had 4/10, which wasn't really relevant to where I wanted to go. What I wanted to pull out was the 12 lots of 1/10. But in the process of giving the children space, children who might not actually previously have accessed the more complex maths are actually really well set up to do that with the building blocks in place. So Eli at the front and Tegan, I heard him say something like, 1.2 metres is 5 lots of 2/10 and 2 more tenths. So that's 6 lots of 2/10. And for that just to be an independent conversation that those two children were having was really pleasing, and I'm absolutely sure not the kind of conversation they would have had the way that I've kind of taught tenths previously.